In this lesson, we're going to add and subtract expressions involving numerical radicals. This is similar to adding and subtracting letters. Only radicals with the same radicand, that's the inside part, can be added or subtracted together. Also, radicals may need to be simplified before trying to add or subtract them. Let's see what we can do. Let's simplify if possible. 9 times the square root of 7 plus the square root of 7. Notice the radicand is the square root of 7 for each case. There's an understood 1 out here, so if we have 9 of them plus 1 of them, then altogether we have 10 times the square root of 7. How about if we look at the second example? 5 times the square root of 3 minus 2 times the square root of 3 plus the square root of 3. Notice inside we have the square root of 3, the square root of 3, the square root of 3. There's an understood 1. So we have 5 minus 2 is 3. 3 plus 1 is 4 times the square root of 3. Let's suppose we want to add the square root of 18 plus the square root of 2. Well, they have different radicands, so at first you might think we can't do anything. However, remember the square root of 18 can be written as the square root of 9 times the square root of 2. The square root of 9 is 3, so we have 3 times the square root of 2 plus the square root of 2. Now they both do have the same radicand. We have an understood 1. 3 plus 1 makes 4 times the square root of 2. 5 times the square root of 3 minus the square root of 27. Once again, 27 and 3 is not the same. 27 we can write as the square root of 9 times the square root of 3. So we have 5, the square root of 3 minus 27. Let's see, the square root of 9 is 3 times the square root of 3. Notice once again the radicands are the same. 5 minus 3, so we have 2 times the square root of 3. What happens if we have an ugly fraction like 3 over the square root of 10 minus the square root of 10 over 5? Let's focus on 3 over the square root of 10 first. Notice that we're not allowed to have radicals in the denominator, so let's multiply the numerator and denominator by the square root of 10. So we now have the square root of 100 in the denominator. This is outside, so we can't put these together. 3 times the square root of 10, so we have 3 times the square root of 10 divided by the square root of 100 is 10. So the problem now has become 3 times the square root of 10 divided by 10 minus the square root of 10 over 5. Now notice these fractions have different denominators. Now the square root, the radicand, is good, but we need to get a common denominator. What's the common denominator between 10 and 5? We need 10. So we need to multiply this by 2, and we need to multiply this by 2. So therefore we have 3 times the square root of 10 over 10 minus 2 times the square root of 10 over 10. Put those together, we get 1 times the square root of 10 divided by 10. That's our final answer. Let's try one more challenging problem. Here we have 5 times the square root of 3 plus the square root of 1/3. 5 times the square root of 3, our radicand is 3. What about the square root of 1/3? Remember, we can write that as the square root of 1 over the square root of 3. Let's multiply by numerator and denominator times the square root of 3. This gives us the square root of 9, which is just 3. This gives us 1 times 3 is 3, so we have the square root of 3 over 3. So this now becomes plus the square root of 3 over 3. So we want to add these two together. They both have a radicand of 3, but we do need a common denominator. This has a 1 so far, so what we need to do is multiply the numerator and denominator by 3 here, so that will give us 15 times the square root of 3 over 3. The square root of 3 over 3, there's an understood 1 in front, so if we add these together, they have the same denominator, so the denominator is going to be 3. They have the same radicand, the square root of 3. 15 plus 1 makes 16 times the square root of 3 all over 3.